All right, so as I said, the algebraic properties, it's the foundation we're using to really do math. Without understanding properties, we can't really do anything mathematically because they're kind of the guiding rules that help us do what we do. And they help us solve algebraic problems or to do algebra. So our standard here is that we're going to solve equations ultimately is our goal. And you maybe have done quite a bit of that before. And we do it because each side of that equation is equal. That's what an equation means. And we can go from step to step to step because we use the properties to find that solution, and we can create an argument that says this is the solution. Remember, I told you, algebra is a journey to the truth. So as a part of our journey to the truth, we have to use properties. So that's the purpose of properties. Now, I would recommend a couple things. First of all, if you look in your Google Classroom, you'll see kind of a slide that it's not really a slide, it's just a document that will point out to you and summarize the properties. If you need to reference back to that, by all means do that. We're going to walk through them just for a second. These are the properties by name. And you've probably heard of them because we've taught them before, the commutative property. Now, one of the things I like to think about is the word commutative looks a whole lot like the word commute. So if you're writing your notes down, write down commutative property of addition. Feel free to abbreviate. You can write commutative the first time and then just write a plus sign if you'd like. Commutative property of multiplication, write COMM, just as abbreviation. PROP for property, put a little time sign if you'd like. Now, commutative looks like the word commute, right? So if you commute to work or you commute to school, the word commute means to change location. When I commute somewhere, I'm changing location. So that's the definition of commutative property. It's changing the order of the add-ins if it's addition, or changing the order of the factors if we're multiplying. And what it means is that commutative property for addition, it doesn't matter what order we add, it doesn't matter what order we multiply, we'll get the same answer. So we can move things around, and as long as it's all addition, or as long as it's all multiplication, the answer doesn't change. The associative property of addition. Okay, so the associative property really says it's kind of similar, related a little bit to commutative property, except it says it doesn't really matter how we group these. We're going to get the same answer. Typically, the associative property has more than two terms. Commutative just has two in the way that we've defined it when we're looking at it there. But associative says, hey, we can group the first two together and add it to the third one, or we can group the second and third one together, add those, and add it to the first. So the associative property, it doesn't matter which two that we group together first. And that's for addition. Notice it says addition. It's also for multiplication. Two other terms there, the additive identity, saying that any number that we add 0 to and get the same number, that 0 is the identity and it's equal to that original number. The additive inverse is very similar to that, and it's really important. If we take a number and we add to it its inverse, then we will get a result, and only one result, that is 0. So every number in its inverse is 0 when we add them. Now, I want to kind of let you know that today, as we're working on this lesson, I'm going to be asking some of you for answers for questions. And the way I'm going to do that is so that it doesn't appear that I'm, calling on one person every time or anything like that. I'm going to just have a random um, selector that will tell me who to call on next. And so you need to be ready to write an answer. Now, it's okay, or to give me an answer. It's okay to tell me you don't know or you need help. I don't care, but I need you to be sure that you're involved with me. So here's my first question. I'll give you a minute to think about what your answer is going to be. And again, I can call you online. I need you to unmute if I do. I can call you here in the class. Okay. So my first question is: we're talking about the additive identity. What one single number is it that we use in the identity to identify? So what is the identity for adding? In other words, I'm going to take a number, I'm going to add the identity to it, which has a specific value, and I get the same answer again. So what is the additive identity? All right? And my random generator says Aaliyah Crooms. What's the additive identity? What number is we use for the identity when we add? Okay, let me say it one more time. Let's say I want to use the identity. I'm going to take, let's say the number 5. What number do I add to 5 to get 5? 5 plus what? Okay, and can you unmute and tell everybody, because we can all hear you in the classroom. Awesome. That's perfect. Okay, so the additive identity is 0. All right. So that's why when we take the additive inverse and put them together, so a number in its inverse gives us 0, gives us the identity. Well, we talked about the additive identity, but let's also talk about the multiplicative identity. Okay? Well, actually, it's almost the same idea. What number do I multiply to get the same number back? What number do I multiply? I get my original number. So for example, the multiplicative identity, if I take a number, multiply it times 1, I get the same number. We all know that, right? If I take 7, multiply it times 1, I get 7. So that's the identity. And then if I take a number 7 and I multiply it by something, I'll also get the identity. I'll get the number 1. Okay. So with addition, I want to get that number 0 when I use the inverse concept. So the inverse, or basically kind of the multiplicative inverse, and that's not on your screen in front of you, but I kind of want you to get it. If I take the number 7 and I multiply it times 1/7, that's its inverse. So 7 over 1 times 1 over 7 gives me 7 over 7, which gives me 1. So the multiplicative identity is how I use a multiplicative inverse to solve things. And you've actually probably done that already. So I need to call on somebody. The question here is, I'll give you just a second to think about it. What number represents the multiplicative identity? So when I take the number 7, what is it I multiply by to get 7? And Michaela Oatley, you're up next. 1, yes. I should pick harder questions. You got that way too fast. Then there's something called the multiplicative property of 0, and I love it. What it says is that any number I multiply times 0 is 0. If I multiply anything times 0, I get 0. And then one that you're going to hear so much about all year long is the distributive property. The distributive property says this. It says if I've got three real numbers, and my problem is written this way, A times, in parentheses, B plus C. Okay? I know because of my order of operations that my grouping symbols dictates that I have to do B plus C first. But sometimes when I'm working with variables, I can't do that. Here's what the distributive property allows. It's what we might call a mathematical workaround. Seems like there's always a workaround to everything anymore. Whether it's technology, we're always a way to figure our way around something. And so the distributive property says I can take A and I will multiply it by each term within the grouping symbols. So I can substitute that for AB. So I took A times B plus AC. In other words, I can take the A and multiply it times every term within the parentheses. Of course, the first mistake I'll see people make is they'll multiply the first two, and they'll just write down the second one without multiplying. That's an easy mistake to make. Now remember, when we're talking about a relation, we're talking about equals to, that sort of thing. Equals is a relation. And the reflexive property says that if this relationship is true, okay? So if 7 is equal to 7, when we flip it around, it's still equal to itself. All right? So every relationship in equality is equal to itself. I guess I always looked at that when I was young as a, well, duh, property. If it's equal, it's still equal. But that's kind of important. And a symmetric property is very similar to that. It just takes it another step. It says if we've got a quantity A and B, and those two are equal, then if we flip sides, B is also then equal to A. And notice what I mean by that. If I say 6 plus 3 is 9, I know that 9 is equal to 9. It really doesn't matter which side, because of the symmetric property, it doesn't matter which side of the equal sign it falls on. And then the transitive property. So the transitive property tells me that if A and B are equal, or if they have a relationship that's true, and B and C have a relationship that's true. So if A is equal to B, okay, and B is equal to C, then that means that first one, A, is equal to the last one, C. That's the transitive. So the words we need to know: commutative of addition, commutative of multiplication. Hopefully you've written all those down. I'm looking around, I'm seeing a few folks I'm not real sure is writing stuff down. I hope you are. And then associative property of addition, associative property of multiplication. All right, and then we had multiplicative identity, multiplicative property of zero. Also mentioned multiplicative inverses. It's not actually on your slide, but we'll talk a lot about that this year. The multiplicative property of zero, if I multiply something by zero, it's zero. And a distributive property allows me to multiply through a set of parentheses to rewrite the expression. Then there are relationship properties: reflexive, symmetric, and transitive. Reflexive just says, hey, if it's 7, it's equal to 7. But symmetric says that if one side, we can really swap sides of an equality, even though those two sides, as long as they're equal or they have a true relationship, then either side is fine. The same thing with the transitive property, but saying that if we have one set of relation that is true, and then we take the second part of that, it's true to the third part, so the first is true to the third. I'll give you a minute to to copy notes. Remember also that all the notes are online for you if you need them. Well, I want to take that just a little step farther and look at some examples. And I'm going to ask you to help me now. If you're in the room and this turns out to be extra small, then log on to the Google Meet. You can see it right there on your computer. It's about to be projected in front of you. And I'm not asking you to write anything down for this, okay? We're just going to kind of do this together, okay? And I'll make it nice and big for everybody. Here we go. I'll have to back out just a little. So we're going to just look at some properties here and match them up. So down at the bottom, the very last property is the zero product. The zero property. Again, if you can't see that in the room, open up that Google Meet, okay? Anybody not see it? Need help opening Google Meet? All right. If you need any help opening Google Meet so you can see it on your screen, you're welcome to do that anytime. Like I said, not only that, you'll get to see the folks at home. Get just absolutely as big as I can. So here's our choices. We've talked about the additive inverse, the multiplicative inverse. We've talked about the commutative property of multiplication, the multiplicative identity. We've talked about the commutative property of addition, the associative property of addition, the distributive property, the associative property of multiplication, and additive identity property, and the zero property. So we talked about a lot of properties in a very short time. So I'm going to call on you. Together, we're going to figure this out. Now, let me remind you that it's absolutely okay to say, hey, dude, or in your case, Mr. Dude, I'm not really sure, so help me out with that, okay? So let's look at this first one. The first one is x plus, okay, so before we get too far in this, what's my operation here? Am I multiplying, adding, subtracting, dividing? What's happening here? Somebody tell me. How about Julio? What am I doing here? Am I adding, subtracting, multiplying, dividing? To go from here to here. Okay. So what does this symbol here mean? You what? Yeah. So I'm adding. All right. So when I go to look at my properties, I know if I'm adding, it's probably not that one. It's not going to be that one. It's not going to be that one, is it? Okay. Especially where I'm adding and I've got parentheses, just like that. So that's almost like a real nice clue. Remember, we're on a journey to the truth, and we want to figure this out. And so I know it's addition. Okay. So the next thing I have to figure out is I didn't move anything except for parentheses, did I? It stayed x plus y plus z. Here it is, x plus y plus z. All right. So I didn't move anything except I put parentheses or grouped them a little differently. So I'm going to give you a couple of choices, Micah. I'm going to call on you here in just a minute, kind of give you a heads up before I do. And I know that I'm going to need either the additive inverse property, the commutative property of addition, or the associative property of addition. Because it's addition, I don't think that it's anything else. So I'm limiting you now to those three. Is it additive, commutative, or associative? What do you think, Micah? And you have to speak loudly because you're far, far away. Let's look at our definition. Let's backtrack this for a minute, okay? Because I want everybody to be able to reference that if they want to. And let me point out something else, too, while we're at it. I added there for you a really cool overview of all the properties that's in there in your, right underneath your agenda. Did I? No, I didn't. Well, I meant to. So let me add that right quick. Let's I put it, hold on, let me put it. Maybe I have, yes, I did. I have it under the wrong date. That's no problem. All right, it's called Properties Chart. And I'm sending it over to you. So you have this real cool properties chart that summarizes everything up. And you're welcome to look at that at any time. I like the way it's written. So we know that we're talking about addition. Okay, and we know that there's an associative property of addition. And there's also a commutative property of addition. Notice commutative has changed the order of the letter. Associative property has put parentheses in different places. All right, so Mike, I'm about to come back to you here just for a second. And my question was, we've got three choices, additive, inverse. I don't think it's inverse because I don't see a zero in there, okay? So I'm down now to two. Is it the commutative property of addition or the associative property of addition? Got a 50-50 shot. What do you think? Absolutely. It's associative property. Outstanding. Good job, man. So it's the associative property because we have changed the way that we've associated these or the way that we've grouped them. So this one is F, associative property. Okay, and I'm not asking you to write any of this down. I just need everybody looking and paying real close attention. I'm going to walk you through some, and then we're going to do some on Desmos in a few minutes. All right, let's look at the next one. PQ times 1 equals PQ. Boy, that ought to be like a gigantic hint right there. And Louise, you're getting this question here. So it looks like I'm multiplying, right? Is that correct? So I'm multiplying here, so I know it could be the multiplicative inverse. It could be the multiplicative identity. It could be the commutative property of multiplication. It could be the associative property of multiplication. So notice that I'm multiplying by what? Multiplying by what here? 1, yeah. Louise, your voice has changed. All right. So somebody said 1 for you, I think. So if I'm multiplying by 1, it's not, I know it's not going to be the commutative property or the associative property because the commutative property says I change the order and associative property says I put parentheses around in different places. So multiplying by 1. Is it inverse or identity? Yes, it's the identity. Very good. Awesome. Next question is going to go to Mackenzie. So let's look at number 3. It's getting a little easier here. Now we know, Mackenzie, is this adding or multiplying in this one? Do what? It's multiplying. Yes, awesome. So the question is now, if it's multiplying, it could be a multiplicative inverse. It could be a multiplicative identity. It could be a commutative property of multiplication. It could be the associative property of multiplication. Do you know the answer? You want me to get it down to 2 choices for you? Okay, we'll get down to 2 choices. So here's the thing. I'm not multiplying by 1, right? And I'm not multiplying 2 things together and equaling 1. See, that would be the inverse. Okay, so that's a good thing to know. So that means now I'm just multiplying and I'm putting parentheses around them in different places. But I have not moved around the variables. It's 5xy, 5xy. So there's one that says the way that I group them is different. Which one is it? Is it the commutative property of multiplication or is it the associative property of multiplication? Yes, very good. It's the associative property of multiplication because I had changed the way that I associate them or the way that I group them. Very good. Oh, we're booking it now. Next person, Maria. Ah, you're up. So get ready, Maria, to unmute there. All right, so here's our question. We're looking at A plus 5B equals 5B plus A. Now, essentially, this is an addition problem, even though there's a little bit of multiplication right here. We're not going to look at that as multiplication. That is a term. So we're adding two terms. And we're adding two terms. So since it's addition, I know it's not the additive inverse because I don't see a zero in there, and nor is it the additive property, the identity property of zero, because I don't see a zero there, because those two would have a zero. Identity inverse would include a zero, as well as multiplicative identity inverse would include a one. So, okay, so now I'm down to, could it be the commutative property of addition or the associative property of addition? Maria, you got an idea?
I think it's the commutative property of addition.
You know what? You think it's right. You got it right. Good job. Awesome. Okay, so it's a commutative property. And why is because we moved those terms. Okay? Let's get number 5 there. Notice here that I'm adding here. Here, I'm going to call this, calling you. You're going to get an easy question. I'm sorry that I'm not giving you a real challenge here. So, what am I adding? Am I adding a 1, a 5? What am I adding? 0. All right. Okay. Easy question for Kira. I'm going to move on. Okay. So that makes it easy because I'm adding a 0. That's a hint. Okay. If I add 0 to A, I get A. So that means it's either an additive inverse property or an additive identity property. Okay. Now let me identify what the difference is. An additive inverse will be two things are added and they're equal to 0. Okay? That's what an additive inverse is. We don't really have that here. Okay, what we're doing is we're adding 0 to it. So, Alejandro, you're next. Alejandro, can you tell me, now I know it's not the associative property of addition because it's included that adding 0. I know it's not the commutative, so I'm down to additive inverse or additive identity. Which one do you think it is, sir?
Identity.
It is. So it is the additive identity. All right, let's go on to number 6. And Carlos, you're going to get this question here, my friend. Okay, first question is, are we multiplying or adding? Well, hold on just 1 second. I've got G written right beside an H. Okay? And that means multiplication. Okay? Really important that we make that distinction because that's going to affect our answer here. If I were adding, it'd be G plus H. Does that make sense? All right, so now, I know since it's multiplication, there's no G times 1 in there, is there? It's not that. And so I know that it's probably, since there's no 1, it's not an inverse property. It's not a multiplicative identity property, but it could be an associative property of multiplication or a commutative property. Okay, so those are your two choices, commutative or associative. Which one do you think, sir? Going to Carlos there. Well, we're close. Associative is not the right answer, and let me tell you why. Okay, it's okay because that's a hard one to distinguish. But which comes first here, G or H? G, right. And which comes first here? H. So we changed the order, right? We changed the way with the positioning of them. So that's got to be the commutative property. Anytime we change order, and let me give you just a little tip. Commutative typically will be 2 terms, associative will typically be 3 terms. And associative will have parentheses, okay? Whereas commutative doesn't necessarily have those. Could have, depending on how you write it, but we're going to keep it simpler than that. All right, so that brings us down to number 7. Let's see who we got up for number 7. And Giovanni. So Giovanni, you're up, my friend. And so here we go. We are adding, and we take an 8 and we add a negative 8 and we get equal to 0. The question is, now if it's got the 0 in there, so it's either an identity or an inverse. A minute ago, I gave you the key there to an inverse. So Giovanni, are you here? Yes? All right, Giovanni. Which one do you think? It's not going to be the commutative property of addition or the associative property of addition because we've got this equal to 0. So is it an identity or an inverse? What did you say? Did you say something? I totally didn't hear you. Did you say inverse? Not your head. Yes. Yeah, that's exactly right. Very good. Awesome. I'm sorry. I absolutely couldn't. It's an inverse because if we take this one and we add it to that one, we get an equal 0. So it's an additive inverse property up here at the top. So what about number 8? I think this is one of the easiest ones to recognize. You know, we've used several already. Okay, we've used F, we've used D, we've used H, we've used E, we've used I, we've used C, we've used A. So now we get down to this one, and we're multiplying x times 0, and we get 0. Okay, so which property says, and actually let me call on somebody here. How about Adriana? It's a 0 product property. Adriana, you're not going to believe this. You looked at me, and I went over here to my phone, and it called your name up. It's like you made it do that. All right, let's go number 9 right quick. This one, we're multiplying 5 times 1/5, and we get 1, okay? So we get, it's equal to 1. So that tells us it's not any sort of an associative or commutative, but it's going to be an identity or an inverse. And the next person up is Haley. Haley, what do you think here? Is that a, what about Emma? Are you Haley? Who's Haley? All right, Haley, sorry about that. We're going to take 5, we multiply it times 1/5, and we get 1. It equals 1. What do you think? Is it an identity or is it an inverse? Yes, ma'am. Awesome. That's perfect. It's an inverse. Very good job. All right, let's get number 10. All right. So here we're taking 2 and we've got a set of parentheses. And so it has in the parentheses A plus B. So now I'm multiplying 2 times A plus 2 times B. And the next person up, this to me is this ought to be the easiest one of them all. The side. What do you think, sir? What? Well, let's give you a hint here. I've marked everything out but 1. Can you see that? Yes. The distributive properties. Is that what you said? I can't really hear you from this distance. Yeah, it's the distributive property. Let me show you why I think this one is so easy, okay? When I say, let's say I came in to class today and I was going to distribute a $20 bill, what would I do? If I say I'm going to distribute a $20 bill, somebody speak up, online or what do you think? I'm going to give every one of you what? What? If I say I'm going to distribute $20 bill to every person? What do I do? Do what? I'd give every person a $20 bill, right? Would y'all like to have a $20 bill? Yes? Yeah, right, me too. You're not getting one, sorry. But to distribute means to pass out, to distribute things, to distribute literature, to distribute candy, whatever. So what I've done here is I have passed out the two, every part of that. That's the distributive property. I think that's pretty easy, really. So that's a summary of our properties for today. What we're going to do next in just a moment is go through the Desmos activity. Any questions? All right, so that summarizes the properties we've talked about. We've talked about the additive or the associative property of addition. We've talked about the multiplicative property, the associative property of multiplication. We've talked about the commutative property of addition, the commutative property of addition. We've talked about the additive inverse, the additive identity, the multiplicative inverse, the multiplicative identity, and the distributive property, along with reflexive, symmetric, and transitive.